Hello and welcome to another Solana tutorial. Today we're gonna talk about offline transactions and durable nonces and that nonsense, which is not nonsense but great stuff that we want to learn about, because I also don't know about that yet. And I mean, I know it exists, I don't know how it works, so I want to look into that and I want to bring you with me on that journey. That's a short intro, but that's okay, let's go. The Solana cookbook has an entry for offline transactions. Wait, let me go here. Create an offline transaction like this. We're gonna go through this today. But first, maybe a little bit of background on block hashes and the recent block hash. So first, let's look at regular transactions on Solana. So I made myself a key pair. I read the private key, create myself a connection to DevNet. Also, while we're here, get myself an airdrop. And now we have a look at sending an actual transaction. Like, I don't know, what do we want to do? Just send some money around? There we go, that's what I need. I just need a simple transfer. And I transfer from me to this guy, Lampert's, I don't know, 1 sol. Cool, that's my instruction. And then I would just be like, put that into a transaction, add the instruction, and then the signature is send and confirm transaction, not raw. That's what we'll do later. So that's the simple way of doing this. Let's do 0.1, such that we don't run out of sol so quickly. And just demonstrate that's the usual way to do things. Doing a normal transfer of some sol with the system program. You should know by now what this is. It's nothing special. And if we execute that, we get a yay transaction signature. Ignoring characters is my style. And then we can have a look at it. And we see I sent 0.1 sol to that other Andy. All right, so far so simple. And that's nothing new. That's neither offline, nor does it have a nonce, nor does it tell you anything about the recent block hash. But we can see inside this transaction, there is a recent block hash. Now, where does that come from? Well, it's in the list of slot hashes. If we go there, oh, I need to go there to see the slot hashes. Let's try that again and be a little bit quicker. This slot hash, the recent block hash was DTMVM. And if we look here, damn it, it's not here. Maybe block hash and slot hash is something different. Let's check recent block hashes. Maybe that is in fact something different. Let's check that out. I'm still learning what all of this stuff is. What's a slot and what's a block? Let's find out. So, there is terminology. What is a block? Contiguous set of entries on a ledger covered by a vote. A ledger produces at most 1 block per slot. One slot can contain a block, but doesn't have to. Where's a slot then? That's the thing with the leader schedule, probably. Period of time in which each leader ingests transactions and produces a block. So inside one slot, in the time of one slot, you can have a block or not. Now that means that block hashes and slot hashes will not be the same, but they have the same timing. In fact, the timing is like, what was it, 150 milliseconds per slot? Solana slot time. 500 milliseconds? Okay, so we have 500 milliseconds. I read 400 milliseconds. Anyway, that order of magnitude, under a second. Block hash is a unique value that identifies a record. Solana computes a block hash from the last entry ID of the block. Cool, we learned something. Which means that's actually block hashes. So we need to check the block hashes sysva to read them. So let's do that again. We will get there, don't worry. So I hit enter here. And at the time when this is coming back, I hit refresh here. So I should get the most recent block hashes. And then I check my transaction. Block hash is C29. And do we C29 it here? Yes, already at position 52, we have that recent block hash that my client put in to the transaction. If I would refresh that now, it's probably not in the list anymore. No, still just about there. So in this 1 minute or so, it went to position 143. All right. By the way, that's the Sysva recent block hashes. So we see there is a recent block hash. Transactions use a previously confirmed block hash as a nonce to prevent double spends. So Explorer already also tells us or gives us a hint what that stuff is used for, to prevent double spends. I should not be allowed to send 2 transactions at the same time which both spend my Solana. So they need to be either this one or this one. It's the double spend problem. How is that connected with the recent block hash? Not entirely sure, actually. But definitely has something to do with security. The way I understand this, you need to have the recent block hash in order for your transaction to be new enough. So in my understanding, we put a recent block hash to prevent a transaction that has been signed a long time ago to still be valid. Because a transaction will only be valid for, I don't know, 150 blocks. Maybe that was the 150 that I read. Where did I read that? There. Your transaction will be rejected if you use an expired recent block hash after 150 blocks. That was the 150. Okay, so after 150 blocks with a block time of, let's say, 500 milliseconds, calculating, divided by 2, because I cannot do that in the head. That's 75 seconds. That's like a minute and 15 seconds. So after a little more than a minute, the block hash expires. And that's counted from the time it was produced, like from the time the block was produced to when the transaction is validated. There can only be 1 minute 15 seconds, which is not a lot of time, because first the client needs to query a recent block hash, so the block hash needs to already exist. The client needs to read it, put it in the transaction, sign the whole thing, send it off to the cluster, and then it's going to be validated. So there's not like that much time. So I can't sign a transaction, wait another minute or 2, and then send it to the cluster, because then it's not going to be valid anymore. And since the block hash is inside the transaction, it needs to already be there before I sign it. And if I change the block hash, obviously the signature changes. So if I change the block hash after the fact, then the signature is not going to be valid anymore. So that's a security mechanism to prevent old signed transactions to still be usable, right? Because somebody could have you sign that you sent 100 SOL to them, and only years later, when your account finally has those 100 SOL, will they execute that transaction. That shouldn't happen. On Solana, if you signed something and that transaction didn't go through, you wait a few minutes, and then you can be sure, if the transaction still didn't go through, that it will never go through, that it's expired for good. And even though you signed it, it cannot be used anymore, because the block hash is too old. The block hash has expired. So it's good that we have this recent block hash in the transaction. We need that for exactly those purposes. That's why we have this recent block hash here. Let's play a little bit, just so we understand better, because all the magic is done within the send and confirm transaction. So let's look at that. There, if recent block hash, else, and if there's no nonce info, we'll get to that, then it will find a latest block hash, and then it sets the last valid block height to that value and the recent block hash. Okay, let's try this manually. Instead of doing this, get a block hash. I think from the connection I can do that. There was a get recent block hash and was replaced with get latest block hash. Promise of block hash and the last valid block height. Then I can put that in a transaction manually, and I'll also log them. Just this for now. Do we get the recent block hash? At height this is this. And if we look here, yep, cool. So that gives me valid block hashes. And that's how many blocks DevNet has already produced. Wow. And then let's see if we can actually send a transaction like that. Sign with signers. Transaction must be assigned a valid recent block hash before invoking this method. We did that. But what are we doing wrong? Oh, okay, okay. We need to put them in flattened like this. I got it. Okay. Because that's an array and then we just have several signers. Okay, got it. So we sign and then we send raw transaction now. Sends a transaction that has already been signed and serialized. Okay, so we need to serialize this as well. So transaction serialize. Simple enough. Oh, I didn't wait. Let's be patient and wait for this. There we go. 3QQ. And the recent block hash was CTA, which was a recent block. Yep, we have that. Transaction went through because we provided a valid recent block hash. Now, just from my understanding, if I were to not provide the latest valid block height, what would happen? It would also work. The last valid block height is not actually that important, I judge. Or can I set that to 1? Even more interesting. Yeah, it seems like it's ignoring this. Because if I can even set it to 1, then, you know. So, good. Well, you know, we don't really need that. I'm gonna leave it here though, just for fun. Good, so that's if we have a valid block hash. What if we don't have a valid block hash? So I put an old block hash here now. And then it says it can't simulate that transaction because the block hash is not found. Obviously, it's not within the last 150 blocks, this hash. So it would just tell me block hash not found, which could also mean block hash expired. Or, you know, I could change it here and then it also says block hash not found. Only if that is an actual latest block hash will this go through. Also, if I send one every minute, let's try that. Hold on. Let's see if I can double send the transaction. Can I send the same transaction twice? Gives me the same signature and then it's probably ignored the second time. I can send it, but it will probably only go through once, obviously. So if I were to build a loop around that, then I could see when the block hash expires. Oh wait, I need the waiting. We wait 10 seconds. Then we send it once. Then we wait another 10 seconds. Then we send it again, even though it has already been sent, but never mind. And that we can now do for transaction has already been processed. Okay, no, we cannot do that for long because at some point the cluster actually realizes, oh, that transaction has already been processed. Don't send it to me again. All right, good. But what I could do is create a new transaction every time. Actually, a good question. If I do the exact same thing and I have the exact same signers and the exact same recent block hash, it will give me the exact same signature. It probably still gives me the same signature though. Yeah. Because all the same values provided means same signature. So that also doesn't change anything. So even if I sign it again, if it's the exact same transaction that does the exact same thing, maybe that's how it prevents double spend. Because you need to somehow be able to tell, was that the one that he signed or was the transaction just sent there twice? Because if the transaction is sent there twice with the same signature, obviously it's the same transaction. So it's not double spent. So double spent in the way of accidentally spent twice the amount, even though I just signed it once. Not the usual double spent problem that I So it's not the usual double spend problem that I think of, that one person can spend the same Bitcoin twice, right? Maybe it's a different kind of double spend that is avoided here. Okay. I'm getting sick. I'm starting to understand stuff. Okay. So, but yes. Okay. So even if we sign twice, if we sign the exact same thing, it's treated as one transaction, because the signature that is created when signing, thus signature, is the same. Wow. It all starts to make sense now. It all starts to make sense, and I'm getting hot. Good. That's the thing with recent block hashes. So we must have a recent block hash in our transaction, otherwise it won't be accepted. Now, obviously that will cause some difficulty, because I will always have to sign within the same minute that I want to send my transaction. But let's assume you have like cold storage that is like super cold, that is like somewhere on a different machine that does not have internet access, and you want to sign a transaction and then move the signed transaction somewhere to a hot machine that has internet access and send it from there. How can we do that? Or just in general, how can we sign offline? Maybe on the same machine is okay, but like, how do I sign without having a recent block hash? Maybe my problem just is that I can't get a recent block hash and I still want to sign a transaction, and then later on let somebody deal with that. Now we finally come to this whole thing. So, offline transactions. To create an offline transaction, you have to sign that transaction, and then anyone can broadcast it on the network. That's the idea. So we have a signed transaction, and then somebody can send it. So there's a create the transaction. But the recent block hash is already put in, and then we sign the transaction. You can verify the transaction, recover the transaction, and send the transaction. And we can even use any library we like. And I mean, we kind of already did this. Here is where we sign, and then, you could serialize that, write it somewhere, and then read that and execute it. So that would be my encoded transaction then. And then I do another one where I just send it. All I do is I do the opposite. Base 58 decode. I would do this, but like this one already expired. And then new transaction from, can I make a transaction from a buffer? We'll see. So here I just do the sending, try that. It should tell me block hash not found, transaction recent block hash required. Oh, because I serialize it. Here I already serialized the transaction, then I encode that in base 58. Send raw transaction, I just sent the buffer. How about that? Null transaction. F that. Just the buffer. Hehe. There, yes, perfect. Then it tells me block hash not found, because obviously that signed and serialized transaction that I put here is already too old. But if I create myself a new one, this is the offline part, and then I'm quick in copying this, pasting it in here, saving this and executing that part, that's the online part now, then I send the transaction. Cool, look at that. And it's the same as before, I just sent 0.1. Point is, we don't need to send it on the device where we create the signature. We can just serialize our transaction and encode that in whatever, for instance, base 58, and then decode it somewhere else at some other device or other program or other script, as I do, and put in that transaction. And then, send it in the raw format, just push out that serialized transaction. So that's the offline way to do it. We didn't really win much. First of all, we're still stuck with that recent block hash, so we need to be quick. And also it's already all done in here because the entire transaction is already ready here. It's just that we don't send it yet, we send it from somewhere else. I mean, could make sense if, I don't know, we have a better RPC somewhere else. The way when that actually makes sense is if we were to, I don't know, split signatures. So I partially sign the transaction here, and then I add another signature here. For instance, this is the client front end, and then in my back end, I add another signature. Then this is the way to go. Maybe let's also quickly have a look at that, because my butt doesn't hurt enough yet from sitting here on this thing. And I just like to make long videos. That's just my style. We get to nonces, don't worry. But then we need to actually split the message from the signatures as they do it here, where they first just serialize the message. That's the data that needs to be signed. And then they sign that twice, once with the fee payer and once with another signature, another signer. And then they recover the transaction by populating a transaction, add signature, or doing it all in one, populate with the set of signatures. And then again, serialize that whole thing again. We can also do that. So let's get ourselves another signer. Andy and Bob. Andy and Bob is always nice. Bob, gonna airdrop Bob to Sol as well. Then I'm gonna send from Andy and from Bob. So I don't know the key pair in here. I just know the address. So Bob also sends 0.1 lamperts to the receiver, just to require both of those signatures. And both of those instructions are added to the transaction. I put in a recent Blockhash. Now I cannot sign with all the signers, but I serialize message. That's the part that needs to be signed. That's just the buffer. And then I print that out. That's the one thing that we will need. That will always be the same if we keep it, the two instructions the same. No, actually, no, it will not, because the recent Blockhash is also in there. So if we execute that twice, then we will get two different things still. Transaction fee payer required. Okay, the sign would usually take the first one as the fee payer, but since we don't do that, we need to say who of those guys is the fee payer. Fair enough. So tx fee payer, you are a public key, so that's me.public key. I'm gonna be the fee payer. Actually, I could have split the fee payer from the send, that I wouldn't even need two instructions on the system program, but it doesn't matter. So it starts the same, but there at some point it's different. So the first part is the same, but then it's different because different recent Blockhash. And apparently here the recent Blockhash was encoded as well. Yeah, okay. So we have the message part. Let's call it message. And then we do the signatures by saying partially sign a transaction, but can I then get the signature out? So yeah, I mean, I'll just partial sign. Let's see what that, I mean, obviously I could just sign the message as they did here. You know, I don't need the Solana library for this. There, I could just do this. I could just use my secret key and sign the message like this. But I want to do it with this partial sign because I can. The library is already here. And I sign as me. Let's see if that prints it pretty. I'll print it once before and once after. Okay, so there's signature null and null. That doesn't sound so good. Oh, did I not save it? That could be a problem. So we have the two public keys and both of the signatures are null. Maybe that's just the beginning. Yeah, that looks better. And then I've provided for the first one the signature. Perfect. And the other one is still null. That's cool. So from the first signature, the fee payer, I want to get, what is it called? The signature. Hehe. That's the signature, and that other part is the message. And I also need to encode that, or want to encode that in base 58 such that it's easier to copy over, because those bytes are like harder to copy. And then in the send, what I will need to do, we have the message, we'll have one signature, and then we'll construct that transaction using transaction.populate. Populate from a message and signatures. So from a message from and then from a buffer, perfect. And the buffer I get from a base 58 decode the message. Then I can say add signature with the public key and the signature. So since we've already decoded the transaction, I think I can now be like tx.feePayer, right? Because that should be already in there, I hope. We'll see. So that's the public key. The signature from the buffer is again, I decode the signature. And then of course I need to add the second signature, or actually I could even just sign additionally as Bob, and Bob is now the key pair that I have on the other side. I'll call this Bob. So I'll also sign as Bob, and then I did the same thing as we did here earlier with just send raw transaction, and we serialize that transaction one more time. There we go. That should work. I'm gonna comment that out for a second, and then we will see that we're missing a signature. So let's do this, and then we'll have to be quick. We will put the message here, the signature here, then try and send this, which should not work. Signature verification failed, but if we add the sign, oh, I should save this. Hold on. And now, still signature verification failed. Damn it. So, okay. Signature verification failed. Maybe I need to partial sign Bob. Does that fix it? Probably Blockhash expired then, but still. Yeah, nice. Blockhash is now expired, but the signatures are valid. Nice. So I then just need to partially sign, so not sign the entire thing, but partially sign, so keep the existing signature, partially sign with my Bob, and then I can serialize that. And that is now a nice use case of having a partial signature in the front end, adding a signature in the back end, and then sending it. So the front end still doesn't interact with the Solana cluster here, we just serialize a transaction, and then this, what I'm doing manually here, this part, the copying over of those two values, this is just, the front end sending something to the back end, the transaction message and the signature, and then the backend executes this part and thereby sends the transaction. Cool. Let's have a look at this in Explorer as well. Now we should send from Bob and from Andy, who is also the fee payer. We send over to this receiving Andy. Cool. That's working great. Nice. We're still not quite at the offline part. I mean, we could now serialize it, that all works offline, and then deserialize it and send it somewhere else. Okay, so we have offline transactions, fair enough. But not like real long-term offline. Like, we're still bound to those 150 blocks of the recent block hash. If I wait too long, this is not working anymore, right? I get the block hash not found. So let's finally talk about, oh cool, partially signed transactions. That's actually what I also just did. Cool, I didn't even look here, but yeah. I mean, you basically did that. We did it a bit differently, but yeah, we did that. Now, we do want to get to that durable nonce, because that is what helps us get over those 150 blocks. And that's one thing that I haven't done before. Also, I have never serialized a transaction, put it somewhere else, but hey, that was okay. That was okay. I'm getting cold again. What is that? I just had Krapfen for breakfast, which is incredibly unhealthy, but I felt like I need some sugar to continue here. Moving on, finally, to Durable Nonces. Yeah, Durable Nonsense. A nonce is a number used only once. Nonce. Yes. And it's gonna replace our Blockhash while still giving us this no double spend property. Because if you can use the number only once, then if you have the same number, it means you still have the same transaction. So only if the number is different, you have a different transaction. Similar to as we had that with the Blockhash. But yeah, let's read what the cookbook tells us here. You can use durable nonce to get a never expired recent Blockhash. To trigger this mechanism, your transaction must use a nonce stored in the nonce account as a recent Blockhash. So instead of the recent Blockhash, we use a nonce, which is stored in an account. And that account we need to first set up. So second, we need to put nonce advance operation in the first instruction. So essentially, we'll create an account with a system program that represents our nonce. And then as the first instruction, we have a increment our nonce, so change this account, add 1 or whatever, to then change that nonce for the nonce to be different. Let's see how that would look. In the transaction, there is a create account for a nonce account and a system program nonce initialize. So that's what we need to do once before, such that this account exists. And this, we can just get it with the get account info, and we can pass it as a nonce account with from account data. Cool, we'll definitely have a look into that, what's stored there in this nonce account. And then we use the nonce account by having as the first instruction a nonce advance of the system program, and then whatever we want to do. And the recent Blockhash will be the nonce of the nonce account. That's all we need to do. Then we can sign the transaction with the fee payer and the nonce account authority. And the nonce account authority authorized pub key. So that's probably the guy that we, when we initialize here, also put as the authority. Okay. So only this authority can advance and close this account. Okay. Yeah. Okay. Cool. Let's just try this. Let's just do this. Let's just start by creating ourselves a nonce account. So we create a nonce account by providing me as the fee payer. The nonce account public key can be any public key, I guess. So I just create a new key, I guess. I'm gonna make myself my own one, simply because I like to do that. This is my nonce now. Okay, so I have a nonce key pair. I really just need the public key, but oh no, I need the key pair because I need to sign for this to create it. Then I need the nonce account length, which maybe is in the Solana Web 3. Yes, it is. Perfect. With the system program, nonce account length. Perfect. And we're gonna look at that in the Explorer, how long that actually is. And we do the init system program, nonce initialize, nonce key pair. And my authority is going to be me. I'm authorized to advance this nonce. Cool. And then I just send it. Me and the nonce key pair need to sign. Oh, send transaction is deprecated. Send and confirm transaction. Me and the nonce key pair need to sign. And then, okay, let's see. I called it nonce tx. Let's see if that goes through. There we go. Let's look at that. So we did a create account and we did an initialized nonce. Both have success. And I paid 0.001, so I would expect that to be, I don't know, a few bytes. 36 bytes is my guess. Maybe a little more. And it is a nonce account. how many bytes it has. Damn it. But it tells me I have the authority. That's the block hash. So that's at least the two things that it needs to store. So that's 32 plus, how big is the block hash? Again, 32, so it's probably 64 bytes. Yeah, not quite. Actually, I could just look it up just because I'm interested. 80. It's 80 bytes. So another 12 bytes. I don't know what it stores. We'll have a look at that. So it stores some block hash in there. And the nonce is initialized with this block hash. What does it store? I don't need that anymore. And now we're gonna have a look at our nonce account. Nonce account from account data, okay? Nonce account info is get account info from our nonce pub, and then nonce account, you said? Yes, can I import that? Yup, perfect. Dot from account data, and I put the nonce account info dot data here. There we go. And then we can see this nonce account. It has a nonce, an authorized pub key, a fee calculator. What is that? Lamperts per signature. Because theoretically that could change. Apparently that's not static. But per default I think it's 5,000 lamperts per signature. So that's also what we saw. Where is it? Here. 5,000 lamperts per signature. So the 0.000005 sol. Anyway, okay, that's fine. We have a nonce account. And how about we just want to sign a transaction now with this nonce? Just normal. We can do it like an online one. Actually, first log some. Ah, the nonce is a string? Interesting. Let's see. What is this nonce? What is this nonce essentially? What is this nonce essentially? Oh, the nonce is the recent block hash then. Haha, that's funny. All right, interesting. And if I advance it, does it then put it to a newer block hash? We will see. So let's do the following. Because wait, I do want to analyze this first. This 3RXE, was that a recent block hash here? Possible. It definitely took the sysvar recent block hashes. So probably it read from the recent block hashes to initialize the nonce. That is very likely. And from the rent, it probably read something else. Anyway, let's do a proper transaction with this. So what do? We just add the nonce advance and put in the recent block hash, the nonce of the nonce account. Because that's also a block hash. That makes sense. Right, so we do the same thing as we did in our online transaction here, except we now need to have a nonce advance instruction, which takes the authorized pub key and the nonce pub key. That should be easy, so that's me. And the nonce pub key is the nonce key per pub key. Here I don't need to sign anymore with a nonce keeper, obviously, because the account was created, so that's fine. Just need to sign with this one. So I need to put that as the first instruction, advanced instruction. I am the fee payer and I am the signer. And then I also just send and confirm transaction. So just to break stuff first, what happens if it's not the first instruct, or if I don't have the advance at all? I'm just curious what error messages I get, because then when I see error messages I can more easily know what I'm doing wrong. Failed to send transaction, block hash not found. Why? Well, obviously it expects this nonce here to be a regular block hash, so it will just not find it. If I add the nonce advance, it will probably still be the same. Yeah, block hash not found. It will again interpret this as normal transaction. What if I have this here as the first instruction now though? What do I now get? Nothing. Because I didn't print my signature. But I think it worked. Let's check on chain. Check on chain. Let's check this nonce, which, let's refresh. Now has a different value. Look at that. 8kx. Hold on, can I refresh this here real quick? But I don't see the transaction of this. Oh yeah, now I see it, okay. So, that transaction that was sent at this recent Blockhash. Yes, that's the one from the nonce, 3rex with a .com. And it worked. It sent 0.1 sol from here to here. And the first thing it did was the advance. And then whatever I wanted it to do. So that has worked. Let's do it again. Recent Blockhash is 8 something. That's my signature. Did the same thing again. That is the recent Blockhash. Had the advance here. In the nonce account, I now have a different Blockhash. Yep, 6G5. Is that here? No, I don't find that 6G5 in the recent Blockhashes. So maybe it does not take the recent Blockhashes to create this new nonce. Or maybe it does and it does some other calculation. Actually, we could look in the source code. Okay, I give up. I cannot find the system program implementation. This is stupid. But okay. Anyway, so it does something to that. I mean, I'm always just getting, sidetracked by all the things that are possible to find out. Anyway, so we see that with every call, the block hash is changed to a new value, a new nonce, wherever it comes from. Let's just accept that it comes from somewhere. Magic, that's where. And that's how we avoid using an actual block hash, a recent one. Because this can now be a very old one. It's just here in this account. And that way we can sign with that. And then the signature is valid for a long time. Let me demonstrate. Because we can now do the same thing as before. We don't need to send that right away. We can just serialize the transaction and keep it for a long time. And then eventually send it. So, as we did here, we could just encode the entire transaction and send it some other time. Or encode like part of have a partial signer and have it be valid for a long time. So if instead of sending it, I were to just encode this, there you go. That's the encoded transaction. And with that, I don't need to be quick. I can grab this, put it on a USB drive, cycle all the way across town, go to an internet cafe and submit this transaction. Something like that. So let's cycle to this hypothetical internet cafe. Here in our internet cafe, we just put in this entire fat string now and send the raw transaction directly from the buffer. Let's do this. Boom. And again, I forgot to print this. Stupid. That's on me. Check that it worked. There we go, that worked, and we see we have a different nonce here in this nonce account, but we did send out this one transaction. If I now send it again from the same encoded transaction, obviously that's not going to work anymore, and it's going to give me a block hash expired. Yes, a block hash not found, because obviously the block hash, so the nonce inside this account has changed. And now to do this, I would need to have this value in there in the nonce, because obviously it can only be used once. That's the whole freaking point of a nonce. Yes, so I can't send the same thing again. I would need to once again create myself a transaction with that recent block hash that I then sign for. Do this again. So now I sign it with the recent block hash, so the nonce that is currently in the account with this 55PA. That's the entire encoded transaction. And this is now valid essentially forever. However, you might be like, well, that's not good. If I sign something and I want to invalidate that, what can I do? Well, glad you ask, my friend. Obviously, there are two things you can do. Both of them target this nonce, because as soon as the nonce changes, this transaction is not valid anymore. So the two possibilities are either advance the nonce with a different transaction, so send another transaction as we did it here, like just do something else where you have a nonce advance, or just do a nonce advance instruction to invalidate everything that used the previous nonce. Or what you could also do is a system program nonce withdraw, which essentially kills the nonce account, I would assume. What does it need? The authorized pub key, well, that's me. The lamports, amount of lamports to withdraw, well, I would say all of them, like the same amount that we had here. Nonce public key is the nonce keeper public key, then to public key. I want the funds. Me. Perfect. This will give me an instruction probably. Yep. New transaction with this instruction. And then I just send it. So if I just close the nonce account, object is possibly null. Why was that not a problem before? Because it's now already unreachable, so it doesn't check that code anymore. This is so stupid. Let me just comment all of this stuff out. So let's close this nonce account by withdrawing all the lamperts. Oh, I signed too much. Yep, I have one signature too much. My bad, but it still works. Which results in, if I refresh this, this should now be an empty account because I withdrew all the lamperts. Account does not exist. And here I essentially moved all the lamperts back, which means since the account does not exist anymore, now I should also not be able to send this transaction anymore. If I were to attempt to do this, it should give me a Blockhash not found. Yep. Because obviously the nonce is not in the data anymore because I killed that account. Cool. And that's that. Now you learned about offline transactions, partially signed transactions, and durable nonces. And you can combine all of these three features as you see fit. You can do all of them at once or just use the ones that are relevant to you. But they're all like somewhat connected. They have a common theme and they kind of belong together. So that's why it's all in one video. So we learned about serializing transactions such that we can send them from somewhere else. We learned about partially signed transactions. And we learned about using nonces. Yes, yes, yes. Cool stuff. Cool stuff. Right. I hope that this video was helpful for you. It's just some transaction sending basics. And you know, those partially signed transactions, especially with durable nonces, they can be really helpful. Like partially signed transactions, definitely if there are several key pairs involved and several entities hold those key pairs, then maybe you want to do it like that. And maybe you want to combine it with a nonce account because one person signs and then it takes forever for the other person to sign, right? So you can combine the partial signing and the durable nonces. And I hope that I also gave you some kind of overview about the security implications of this. Because obviously, if you use a nonce, that transaction stays valid, even though it might not have been sent yet. And then it can be sent some later time. So in my opinion, it's good that the default is to use the recent Blockhash and not have transactions be valid forever. But it's also very cool that you have the opportunity to set up such a nonce account and have your transaction be valid for long. Yes, that's pretty cool stuff. All of the links to those resources and the source code that I wrote down in the description. I definitely learned something today. Hope you also learned something. Join me again in the next video. I make videos every week now since I quit my job and I have time. Score. Also check out those. And then I'll see you in the next one. Till then, bye bye. See you next time for more nonce. It's just such a nice pun to make with nonce.